Hi everyone, welcome to a TESS Academy YouTube video. This is part of our GCSE Chemistry Revision Lesson series. Today, we'll run through displacement reactions and redox reactions in terms of electrons. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements, or suggestions to us through the website. Thank you. Now let's talk about displacement reactions. You should know that as you go down the reactivity series, the reactivity of all the metals decreases. If there were to be a reaction between two metals, the more reactive metal would displace the less reactive metal from its compound, almost like it's pushing it out of its compound. Therefore, reacting a more reactive metal with a metal oxide that has a less reactive metal incites a displacement reaction. For example, zinc reacting with copper oxide gives you zinc oxide and copper. This can be explained as you can see in the reactivity series, zinc is higher up than copper, showing it's more reactive. Therefore, zinc displaces copper from its compound and copper becomes reduced because it loses oxygen. To learn the reactivity series, you can use the mnemonic provided here to remember the order of reactivity. Please send lions, cats, monkeys, and cute zebras into hot countries, signed Gordon. Each letter assigns with one metal. Displacement reactions in aqueous solutions. To compare the reactivity of two different metals, you can always use a reaction with a salt solution to create a displacement with the metals. When the two solutions react together, the more reactive metal will displace the less reactive metal, which slowly disappears from the compound. For example, this can be displayed in a reaction between magnesium and copper, when you react together magnesium powder and copper sulfate solution. Magnesium displaces copper as it's higher up on the reactivity series, and as copper is displaced, it forms a solid metal and falls to the bottom of the beaker. This can be seen in the diagram, where you can see the magnesium as a solid previously, before the reaction, and once the reaction has occurred, you can see that magnesium sulfate has formed, which is a solution and therefore has changed colors, and you can see that copper has formed at the bottom of the beaker. Now let's look at redox reactions in terms of electrons. Firstly, remember this acronym that oxidation is loss, reduction is gain, i.e. oil rig. This refers to the idea that oxidation is the loss of electrons and reduction is the gain of electrons. Reduction and oxidation can happen simultaneously, hence why we can use redox reactions as an abbreviation. In this slide, you can see a list of all the ions you have to memorize for your exams. It's crucial you learn these for equations like half equations or ionic equations, as this information is not given in the formula booklet. Additionally, some of the ions are very similar to one another, for example Fe2+ and Fe3+, but they have very different processes and chemical reactions which you need to be able to distinguish also. Let's look at an example of a redox reaction. When iron atoms react with a dilute acid, they lose electrons and become Fe2+ ions. A balanced equation of this would look like iron plus hydrochloric acid provides you iron chloride plus hydrogen. A balanced ionic equation would look like iron plus H+ gives you Fe2+ plus hydrogen. The iron atoms are oxidized as they lose electrons, as you can see in the half equation, and the hydrogen ions are reduced as they gain electrons to become an atom. Half equations illustrate oxidation and reduction individually with different elements. It's crucial to be aware of how displacement reactions look like in terms of the balanced and ionic equations. So for example, we know that magnesium displaces the copper within copper sulfate, so using ionic equations we can see which reactants are undergoing reduction or oxidation. Firstly, the full chemical equation of this reaction is magnesium plus copper sulfate gives you magnesium sulfate plus copper. Once we write the ionic equation, all we're showing and displaying now is the ions by themselves. So magnesium plus copper ions plus sulfate ions provides you magnesium ions, sulfate ions, and copper. Then we can use the ionic equation to find any spectator ions and ignore them. So for example, we can see that in both sides of the reaction, on the reactant side and the product side, we can say sulfate ions present. Then we can use the ionic equation to identify the species that is oxidized, i.e., remember that oxidation is the loss of electrons. We can see that magnesium over here becomes magnesium ions as it loses 2 electrons. And additionally, we can use the same ionic equation to find the species that is becoming reduced, so any elements that are gaining electrons. So over here we can see copper ions gaining 2 electrons to become a copper atom. Let's put the knowledge we have just learnt about displacement reactions and redox reactions into practice and answer a few questions. We'll complete this MCQ first. Have a go at this independently and then return back to the video to correct your answers. Firstly, which of these elements can be displaced by calcium? Is it potassium, sodium, aluminium, or lithium? The answer is aluminium, as calcium appears in the reactivity series before aluminium. Let's try a harder 6-mark question. The same way that we went through the previous equation using ionic equations, we will try to replicate it here. Once again, try to complete this question independently and return back to the video for some corrections. The question is, zinc displaces copper from a solution of copper sulfate. Using ionic equations, determine which species undergoes oxidation and which species undergoes reduction. This is a 6-mark question, so remember to include as many details as possible. Let's go through these corrections. Award yourself 1 mark for each of the following sentences. The first thing we will start off with is a balanced equation. So you can see over here that zinc plus copper sulfate gives you zinc sulfate plus copper. Then you can write the ionic equation. So zinc plus copper ions plus sulfate ions gives you zinc ions plus sulfate ions plus copper. You can see that over here, zinc is losing 2 electrons, so zinc has been oxidized as it's losing electrons. And you can see that copper is gaining 2 electrons, therefore copper has been reduced. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for key stages 1, 2 and 3, along with specially formulated 11+ GCSE and A-level lessons. Further information can be accessed on our website at TESSOnlineschool.com. And if you would like further resources, advice and feedback, please contact us on the following numbers. Thank you.